moon. Isn't that something we learned last week in math class?
This is the moon I saw earlier. Isn't it a parabola?
Yes, it is a parabola.
This is an example of an untranslated parabola that resembles the crescent moon. It opens to the left. The equation is y squared equals negative 12x. The vertex is at 0, 0 because the graph is untranslated. To find the vertex, we use the equation negative 12 equals 4p to find a focus of negative 3, 0. The directrix is the same distance away from the vertex but in the opposite direction and is perpendicular to the axis of symmetry. In this case, the directrix is x equals 3. We have plotted out some points on this graph. 0, 0, negative 1 plus or minus 3.46, negative 2 plus or minus 4.9, and negative 3 plus or minus 6.
Here's another example of a conic, the St. Louis arc that represents a parabola. In this picture we have the graph of the equation that represents the St. Louis arc. The equation is negative 2y equals the quantity of x plus 2 squared. First, we're going to find the vertex using the translation vector negative 2, 0 to find the new vertex of negative 2, 0. Next, we must find the focus. First, we must find the value of p, which is negative 2 equals 4p, so p equals negative 1/2, making the focus of the untranslated one 0, negative 1/2. And after applying the translation vector, it now becomes negative 2, negative 1/2. The directrix is the value of p going the opposite direction and is the line that is perpendicular to the axis of symmetry of the parabola, which makes it y equals 1/2. Next, we'll find a table of values for the parabola.
Okay, so maybe there are parabolas. But what else can there really be?
There are plenty of other conic sections in this world.
What you talking about, Willis?
As seen in this picture, the conic section, the circle, can be represented by the Texas star.
This is an example of an untranslated circle. As we see, the equation of this circle is x squared plus y squared equals 36. Because it is untranslated, the center is at 0, 0. To simply find the radius, all we have to do is take the square root of 36, which is 6. So, using this fact that the radius equals 6, we can find 4 points on the graph to map out.
Hey look, it's the Epcot Center ball at Disney World.
Yes, that's another example of a circle.
The Epcot center ball is an example of a translated circle. Just like the untranslated circle, we can calculate the radius by taking the square root of 36, which is 6. The main difference here is that the center is located at negative 8, negative 4 instead of 0, 0. We know the center is at negative 8, negative 4 because h, negative 8, is subtracted from x, and k, negative 4, is subtracted from y. Here are some examples of points on this graph.
I think I'm catching on. Just like my favorite math teacher, Miss Newton, taught me, this is an ellipse.
That's correct.
This ellipse is a representation of the track in the previous image. It is represented by the equation quantity x squared divided by 9 plus quantity y squared divided by 16 equals 1. To find the vertex, we take the square root of a squared, which is 16, and get 4 and negative 4, and map it along the vertical major axis. The vertices are 0, 4 and 0, negative 4. To find the co-vertices, we take the square root of b squared, which is 3 and negative 3, and map it along the horizontal axis. To find the foci, we simply take 16 minus 9, or a squared minus b squared, and get 5. We take the square root of 5, and that is mapped out on as positive and negative values along the vertical major axis.
Hey look, another ellipse, the Roman Colosseum.
This is the graph of the Roman Colosseum. First, identify the vertices, co-vertices, and the foci. Make note that a squared equals 9 and b squared equals 4, so a equals 3 and b equals 2. The denominator of the x squared term is greater than that of the y squared term, so the major axis is horizontal. You can find the vertices by taking the value of a, which would be positive or negative 3, and then adding it to the center of 3, 2, making it 0, 2, and 6, 2. To find the co-vertices, take the value of b, which is positive or negative 2, then add it to the center of 3, 2, making it 3, 4, and 3, 0. After you have found the vertices and co-vertices, find the foci. You can find the foci by using the expression c squared equals a squared minus b squared. You already know that a squared equals 9 and that b squared equals 4. Using that knowledge, find c squared by getting the difference of a squared and b squared, which is 5. Then take the square root of that, which is the square root of 5. Then add to the center 3, 2, making it 3 plus or minus the square root of 5, 2. After you have completed that, plot all the points on the graph and connect the vertices and co-vertices to create the ellipse. There are even conic sections in Michigan.
Just like the 3-point lines on the Michigan basketball court.
This is the graph of the 3-point lines on the Michigan basketball court. First, the equation is y squared over 9 minus x squared over 16 equals 1. We know the center is at the origin because there is no translation. To find the vertex of the graph, we must find the value of a. A is the square root of 9, so a equals 3. It has a vertical transverse axis since y is positive, so the vertex is 0, 3, and 0, negative 3. The value of the focus is c squared equals a squared plus b squared, so c squared equals 9 plus 16, so c equals 5, and lies on the vertical transverse axis, so the foci are 0, 5, and 0, negative 5. The asymptotes are y equals positive or negative a over b times x, so y equals positive or negative 3/4 x. Draw the smooth curve through the vertex that never crosses the asymptotes, and that is your graph.
Another example of a hyperbola is the Kobe Tower in Japan.
What's the Kobe Tower?
I don't know, but it's in Japan, so it's pretty important.
This graph represents the Kobe Tower. The equation is quantity x minus 1 squared divided by 4 minus quantity y minus 2 squared divided by 9 equals 1. Since the translation vector is 1, 2, the center is 1, 2. Next, to find the vertices, we must find the value of a. A squared equals 4, so a equals positive negative 2. If this graph was untranslated, the vertices would be 2, 0 and negative 2, 0. With the translation vector, they are negative 1, 2 and 3, 2. To find the foci, we must set c squared equal to a squared plus b squared. In this case, c squared equals 4 plus 9, so c equals square root of 13. If the graph wasn't translated, the foci would be positive negative square root of 13, 0. But it's translated, so we apply the translation vector 1, 2. So the foci are 1 plus or minus square root of 13, 2. The slopes of the asymptotes would be positive or negative b over a, or positive negative 3 over 2 in this case. We plugged the center 1, 2 into y equals positive negative 3 over 2x plus b. To find a b value of 3.5 when the slope is negative, and of 0.5 when the slope is positive. So the asymptotes are y equals 1.5x plus 4.5, and y equals negative 1.5x plus 3.5. Draw a smooth curve through the vertices that never cross the asymptotes.